welcome everybody to another episode of our Puget Systems podcast live Q&A show. Today we are a day past where we normally would broadcast because we wanted to coincide with the big topic for today, the launch of Intel Xeon-W 3300 series processors. I suppose this is the next step for the Ice Lake architecture CPUs. And we're going to be going over, the performance testing, kind of where it might fit into our product line, what it's good for, what it's not good for across scientific computing, 3D animation design, that sort of thing, and also, of course, content creation. So I guess we'll just jump right into it. Any of you gentlemen would like to start off?
Before we really get into stuff,
Sure.
I guess one thing we could talk about is like what the capabilities are, because they did some nice things with this platform. They versus the previous Xeon W's, what is it? It's gone up to PCIe Gen 4, which is great, and it's 64 lanes, which to me I don't see much of a point in having more than 64 lanes right now, because we can't even really do quad GPU much. So 64 lanes would be, x16 for 4 GPUs. So that basically means since we can really only do triple GPU in most cases now, that leaves another 16 lanes for, M.2 stuff. So really, the fact that it's less PCIe lanes than like Threadripper Pro, which is 128, to me it's like, whatever. At that point, like it's the same. Like, who cares?
Just bragging at that point.
It's really hard to saturate that many lanes at one time.
Yeah,
especially Gen 4.
Threadripper uses those lanes for internal stuff too.
Mm-hmm.
Oh, okay.
So it's not all to the PCI bus, but yeah, it's nice.
It just means I do like that we're basically at the point on a lot of these platforms that PCIe lanes just doesn't matter anymore, which is great.
Yeah.
Once there's enough that you don't have to have that as like a factor in figuring out what you want to buy, great. What else did they do with these Xeon Ws?
Didn't they increase the RAM?
I see 8-channel memory.
Yeah, it's 8-channel, and now you can go up to 4 terabytes. Is that right? I think it's 4 terabytes.
I think that's what I saw.
Now, I mean, it's 4 terabytes, but that's only using like crazy registered ECC sticks that are almost impossible to get. But again, it effectively means that you can, whatever sticks you can get, you can put in there. So if you can get 256 gig sticks, great. Now you can do 2 terabytes of RAM, and it's fine. And the other great thing is now there's not a bunch of different models. I don't know if it was as much on the Xeon Ws, but on the server side, like they used to have like high RAM capacity models and normal models, and I think they've largely gotten rid of that even on the dual Xeon, which is terrific. So I think that's the main things is like the more PCIe lanes in Gen 4, faster memory and more memory. And I guess there was an increase in core count. They have the 38 core CPU, which is a weird one. We found it was a very much a weird one. But we'll probably kind of get into that a little bit. Unless, Don, you want to kind of tackle that.
Yeah, Matt, they this is also 8 channels, memory channels here, and I have a test that actually shows the effect of that really pretty well.
Oh, cool.
And that's matching the 8 channels on the Threadripper Pro also.
Yeah.
So that was a welcome improvement because the former model and the second gen of Xeon Scalable, which this is really from, was a 6-channel, which was nice at the time. But then the AMD came out with Epic, and they did 8 channels, and man, when you need that, it's like a showstopper. So, and we have customers that like, that's their performance limiting factor.
Yeah. Well, and Don, I remember the other thing that they have on these is like a deep AI boost stuff.
Yeah.
Did you get into any of that stuff?
No, I haven't. There's some architecture changes that are pretty cool, actually. And they have this DL boost. They've added a new like data type that's supported in the hardware. The BF16. It's like it's kind of the equivalent of like NVIDIA's FP16, like what they use in the tensor cores. There's some stuff there, and that actually for stuff like machine learning inference, that can really shoot your performance up. So there is some features in here, but a lot of that stuff is really new and it's not really exploited. I'm actually looking at some benchmarks that will be using some of that core stuff there. Their OpenVINO, their CPU side machine learning stuff. There's times when the CPU does a really pretty nice job. I mean, I'm a big GPU fan, but I have to say that it's actually not bad.
Cool.
So, but again, before like we jump into
Sure.
like performance and testing and all that, I do kind of want to talk about two of I don't want to really call them like elephants in the room, but like two issues that we came across in a lot of our testing, just because I think it phrases kind of like at least what I'm going to talk about, because I'm going to talk about what I want to preface it with this. The first that Don, you might have the best input on is the 38 core is a weird model because of how Windows handles higher number of core counts. So once you get above 64 threads, so that'd be 32 physical cores, Windows has to break it up into 2 logical processors. So it kind of treats it like it was a dual Xeon. And so that's not just Intel, but that's like the Threadripper 64 cores do the same thing.
Interesting.
So you get into weird issues then if like an application is not super well threaded. Like say it's going to use 2 cores. It's possible it could use 1 core on one of these logical processors and another core on the other if like the app isn't very good about knowing how to handle that stuff. And so then you can have problems with like this logical processor is trying to access memory across from the other one. Same issues you have with like dual Xeon.
I was going to say it's like a virtual dual Xeon. That's weird.
Yeah. And it's a Windows thing. So I think that's one of the reasons why, at least, especially in my stuff, because a lot of my stuff is more lightly threaded. I saw some weird stuff with the 38 core and a little bit more inconsistency in the results. I had to run some things more times than normal to get like a result that made sense. I think it might be because of that. And I think it's especially bad on the 38 core because you have basically 32 cores on one logical processor, and then you have 6 on this other one. Versus like Threadripper Pro or Threadripper, you have 32 and 32.
Sure.
So that might be.
Yeah, this is a hard one, Matt. I mean, this is really confusing because that looked really bad, and I'm going, what the heck? Especially some of the results that Kelly's got. It was like, oh man, what is going on there? It just didn't make any sense. And and in fact, I think Kelly's got the most disturbing result with the compilation, the compiling performance. That one was like, oh, that made me cringe.
I think Matt and I both have very weird results for very different reasons. Mine's because of the 38 core. Matt has weird results because of power management, and it's very bizarre launch.
Okay, I've got to say, I did like this. My testing all on Linux. Okay. I mean, I didn't even have a desktop installed, and it was
bragging over
perfect.
Here.
It's fantastic.
Don doesn't even see the code. He just.
But I was so disturbed. Matt, especially, I went back, just like yesterday or whenever I went in and while it was up in Windows, and I ran some of the Python benchmarks because I knew I could put the load on it. And I could use MKL and all that stuff, and I could look. And I did look at scaling. We had the 38 core in the system at that time, and it scaled reasonable from the 32 to 38. I didn't see any weirdness, and I looked at scaling, dropping it back all the way down to like 8 core. I didn't do extensive testing. I just wanted to see if I could break it. I mean, I was really trying to break it, but it worked okay. So I'm still scratching my head about that. But man, yeah, that was. If we're talking about the good and the bad and the ugly on this one, that's definitely falls into the ugly category. That was the troubles that you guys ran into with that were like, whoa, totally unexpected.
Yeah. Well,
Um,
and then the other issue that Kelly was mentioning that I ran into most was the power draw or power profile. So nutshell, and we'll
Interesting.
get into my results more, but in a nutshell, we saw a lot lower performance, especially in lightly threaded applications when we were using the default Windows power profile, the balanced power profile, which is honestly what most systems, I mean, it's what all systems we ship out or ship with, but if you were going to buy this from anybody else, I almost guarantee you it's going to be using the balanced profile by default. And it was massive. Like, I'll have a few things, but in one case, I think it was like 3 times higher performance when we switched to high performance. So that was the other issue we ran into is that the power profile makes a big difference. And the main thing between the two power profiles, balanced and high performance, is the minimum processor state. So when it's idle, on balanced profile, it can go down to 5%. On the high performance profile, it runs everything at 100% all the time, and which is good if you're looking for maximum performance. But it's going to be in like short spurts where it matters, because if you have a sustained load, like a lot of your stuff, Don and Kelly, your rendering stuff, like it's sustained load. It's never going idle for the whole thing it's doing. A lot of my stuff, it's more like short tasks that are getting done over and over and over. So it has to jump up and down more. But it is weird that it has that big of effect because, I mean, Threadripper Pro, Ryzen, Intel like 11th gen, no issue. You see minimal difference between the two power profiles. It's just Xeon-W, and we actually did see this on X299 as well. So I think it might have something to do just with that whole. I mean, I know it's a different architecture than what X299 is, but I'm sure it's based on a lot of the same stuff.
I had a few instances where Threadripper, especially the 16 core, was actually slower on performance than it was on balanced.
Weird.
Yeah, I had a few like that too. It's weird. It's like, no, just switching to high performance pro profile for whatever reason doesn't always give you more performance. It makes your system louder and hotter and draw more power, but it's a weird one.
Yeah, I had just a little bit of a thought on that this morning, because I was going, why would it possibly do that? And the one thing that, and this is something that I really kind of don't like about the current vector units on these, and you mentioned that the X299, this same kind of thing showed up. If you've got something, if it for whatever reason is going to activate the vector unit, the AVX 512 in this case, that shifts the whole thing into a different power profile, because the way this didn't happen with AVX2. AVX to AVX2 doubled the performance. It was just killer. It didn't drop any clocks. But on these with the AVX 512, the clocks drop when the vector unit engages, and that can affect the total core performance. And so if you've got something that's like popping in and out of the vector unit, and because that's a big vector unit, so anything that's going in there is going to happen one clock cycle. So if you've got stuff that's loading in to the vector unit, knocking out in one clock cycle, that power is still dropping and then back up. So it's basically would be kind of like bouncing around. That's just a theory. I don't know, but it kind of makes sense, especially since it's shown up before. And you're right. I wouldn't see it because the stuff that I'm running, man, that thing is maxed out and it's just cranking.
Mm-hmm.
So it all settles into that state. But yeah, I that's kind of my suspicion. I don't know.
Yeah.
It shouldn't happen. It shouldn't happen.
Shouldn't.
Yeah,
but it's been happening.
And it did.
When was X299 launched? Are we like 3 years? So
it's been a while.
It's been a thing. And for us, what we did with X299 is we just had our own power profile that just changed the minimum. It basically matched the high performance power profile for the CPU stuff, but it didn't affect like the hard drive spin down times and sleep and all that kind of stuff. And so on like X299 systems, we just shipped it that way. We don't really ship X299 anymore because Ryzen and Threadripper just made them largely moot. So we haven't had to deal with this, for a little while. But yeah, like on these systems, I think our plan is to ship them in balanced, because in a lot of the workloads that we're going to be recommending them for, it doesn't matter. It didn't come up. And
Yeah, I
then
tested them.
yeah, and then just, maybe have like a support guide or support knows, or our sales guys, if it is being used for something else that it could be affected, like, hey, you might want to tweak the power profile. I mean, it's like one click, it's one button.
Yeah.
It's not hard to do, but that way we're not running all these CPUs at 100% all the time, even when they don't need to be. Or I'm not even sure how it works with like throttling, because there's also like Intel Speed Step and Turbo. These processor power states, there's so many different of them. Honestly, I don't quite understand how they all work together, because it's all weird. With that,
All right.
I guess.
Do we want to get started on the?
Yeah, sure.
Yep. All right.
I can
You wanna
talk
start
about
or
my
you
stuff
want me
since
to?
we're talking about power
Okay.
profile stuff.
Yeah. Okay.
You want to? There we go. So just going through the things I tested was Photoshop, After Effects, Premiere Pro, DaVinci Resolve. Really, between those, Resolve is the only one that would be a real possible workflow. But it's always good. I like to do all this kind of testing anyway, because like Photoshop, for example, you're not going to be using this for Photoshop. You're not going to be using Threadripper Pro for Photoshop, but it's pretty much widely used in like any content creation field. So it's good to know if there is something weird. It's good for us to find it. So I'm not as concerned about the total scores, but this was one of the ones where we again saw my mouse is on the wrong one. The performance changed a lot. So this chart is kind of a combination. In our articles, we separated out the balance profile and the high performance. This is just mashing it together so we can kind of see this at a glance. But basically, we saw around a 20% performance gain in the high performance. But even at the high performance, I mean, Photoshop is very lightly threaded. Most CPUs are going to have very similar single-threaded performance until you get to the really high core counts, like the 64-core Threadripper Pro, where it has a slight drop. But it basically means like they're all within margin of error as long as you're using the high performance profile. And that's very typical. You can get a little bit higher performance out of something like Ryzen or the 11th gen Intel stuff, because they have a little bit higher single core performance. But if you're using Photoshop as a secondary app, it's fine, but you are going to notice a performance hit if you use the default balance profile. The other one that was even more significant, this was probably the worst offender for the power profile stuff, was After Effects. In After Effects, there is a small use case for the Xeon-W or Threadripper Pro. Because of how After Effects works, if you have a ton of RAM, that can make a really big difference for higher end workflows. And so, 2 terabytes, 4 terabytes even is not outside the realm of possibility for these like super crazy high end motion graphics or VFX workflows. So there is a use case here. And yeah, it was crazy how much faster we could get with the high performance power profile. Like you see this overall, like at most it was like an 80%. And that took it from like half the performance of Threadripper Pro to essentially on par. And you'll actually notice here that, like what Kelly was saying before about the 2 power profiles, these 2 Threadripper Pros actually saw a performance hit in high performance power profile. So you kind of have to compare balanced with Threadripper Pro to high performance with Xeon. And it's not a big difference. It's like 5%, which you're not going to notice 5%. So again, the end story is if you're using high performance, Xeon-W, Threadripper Pro, about the same. So it's not a huge thing. But I also wanted to point out on this one was one specific category of our tests in After Effects, which was tracking. So 3D tracking, camera tracking, that is where a huge chunk of the performance hit with the power profiles came in. I mean, one of these, the 32 core, it was like 3 times faster with high performance power profile. So that's massive. And this is tracking in After Effects right now is entirely single threaded. But I think like every frame it's doing tracking, it might jump to a different core. So I'm wondering if like it does tracking in one frame and then it jumps over to another one, and so then like that core has to like spin up all the way. So we're getting a lot of spinning up and down on this. And so that's why I think we might be having this exaggerated, really, really bad performance in the balance power profile. Because that's bad.
Bad.
That's really bad.
Yeah. Well, and it's actually funny because we started our testing when we first got samples, and the system was in high performance power mode. I don't even remember why it was already in it, and we did our testing. I'm like, yeah, okay, everything looks good. And then we started doing our testing for like these actual articles. It's like, whoa, something has changed, and it was because we had done an OS reinstall, and that reset back to the balanced power profile. So this was one of the first places where we like noticed that, okay, what's going on here? And then we remembered X299. And so then we got going into this. So again, in the end, you can get about the same performance. But man, if you're worried at all about power draw, even noise to some degree, and all of that, Threadripper Pro is really kind of the way to go with this if you need high amounts of RAM.
I wanted to jump in real quick. There was an interesting question related to the core count issue we mentioned earlier. Drone Video on YouTube asked, does Windows Pro for Workstation suffer from that same core count issue?
Pretty sure, yes. It's like a core to Windows that you have to separate it out into logical processors. Windows 10 for workstations, I think what it allows is like multiple physical and like crazier higher amounts of RAM. Okay. Is that right? It's been a while since I've had to even look at it.
That feels right. I think there's something about like a maximum number of like physical actual CPUs on the board or something like that. Right?
Yeah. Windows 10 for workstation, like when we really look deeply at it, it's been a little while now. We basically found that like, nah, it doesn't matter. Don't worry about using Windows 10 for workstation. It's unless there's a very specific thing that it allows, it's gonna behave the same. And yeah, I think it does come down to like total memory and physical CPUs. Don't quote me on that because again, it's been a little while. So like in this case, if you were going to do 4 terabytes of RAM, maybe you would need Windows 10 for a workstation, but it won't affect performance at all.
I know we do have a few articles from early February of last year looking at the Threadripper 3990X and Windows 10 for workstations and how it relates to Adobe CC performance.
Yeah, I should remember because I wrote those. But
that's when the Windows Pro for workstation really came to light, was when we exceeded 32 cores for the first time. But I think it's all works now on just regular Windows Pro.
Yeah, I think so too. When like the AMD Epic came out and the 64 core Threadripper, there were some vendors that were only shipping the systems with that Pro for workstations. That was like right initially they were doing that, but I think I think you're right, man. I think those issues are just gone away.
Yeah. Well, I remember too. Also back then, it was also annoying for us to install Windows 10 for Workstation because it was an upgrade only. So you couldn't just like install Windows 10 Pro for Workstation. You had to install Windows 10 Pro and then upgrade to Workstation, which was kind of annoying. Hopefully now you can do it. I see someone posted on a thing that it was 2 physical CPUs and 2 terabytes of RAM.
Okay.
So if you have more than that. So not many people are going to have more than 2 physical CPUs or more than 2 terabytes of RAM and be running a, standard Windows, not server.
I don't know. Someone out there might be having one of our quad Xeon systems out there. I'm just saying.
And not
but all those people, all those people are also going to be running Linux. That's the thing is, they're just going to get around Windows.
Yeah. So to finish up my stuff, so After Effects, Premiere Pro is one. It wasn't as big of a deal. It was interesting because the lower core counts, like 16 core, minimal difference. But as you went up in core count, it made a bigger and bigger difference in terms of what the performance was. So it made it basically where all the Xeon-Ws were essentially the same on balanced power profile to when we went to high performance. Then you actually got, it's not great scaling, but it's a little bit of scaling. But really in the end, like, if you're going to be shelling out for this level of a platform, to be honest, you're probably not going to be getting the 16 core, especially for like Premiere Pro, because you're not doing it for the RAM. You're doing it, or the PCIe lanes, you're doing it for the CPU performance. And so you're probably going to be using, the 32 core Threadripper Pro. And at that point, it's faster than Xeon-W. So even with the balance profile, unlike Photoshop and After Effects, where it's like, if you change the balance or change to high performance, Xeon and Threadripper Pro are about the same. And Premiere Threadripper Pro is probably just going to be a hair faster. I mean, it's not massive, but it would be a little bit faster. And then the last one I had, these are kind of in reverse order. There we go. Was DaVinci Resolve. This is a little bit harder to read because this is by the core count rather than like performance. But there was a few things in here. First of all, yes, the power profile did change performance by 15 to 30%. And it made it worse again on some of the Threadripper Pros. The 64 core did make it better. But the thing here is the 38 core actually saw a performance hit. And generally in Resolve, you don't see much of a benefit to higher core counts, just like going from the 32 to 64 core Threadripper Pro. But you generally see a hit. But we actually saw a hit here. And I wonder if it's that whole logical processor group thing in Windows going on here. But this Xeon-W, though, at least is way better than the previous generation for Resolve, especially because you have all those extra PCIe lanes in their Gen 4, which in Resolve is big on GPU, especially in higher-end workflows. A lot of times the GPU is the bottleneck. And so being able to have more lanes is really, really, really good. But the other thing I wanted to bring up here was Fusion. Basically, it's After Effects. It's motion graphics and VFX. So same thing as After Effects, just different app. And this one, again, was a huge performance difference in the two power profiles. This one wasn't 3 times like After Effects, but it was 2 times. And maybe I could get more because I don't think we do much tracking tests in Fusion. But if we did, maybe it would be close to that. But either way, if you are going to be doing like DaVinci Resolve and you're doing anything with Fusion, like, man, you got to be running in that high performance power profile. But like the summary of that is, even for DaVinci Resolve, I give the edge to Threadripper Pro, but it's not a big edge. Like if you're comparing the 32 core Xeon-W to the 32 core Threadripper Pro, I mean, that's basically the same score. It's within a few percent if you go to high performance. But the Threadripper Pro, I think it's like $1,000 cheaper than the Xeon 32 core, like $950 or something like that. Which honestly, though, if you're buying a system of this class, like it's probably going to be an $8,000 to $10,000 computer anyway. So I mean, that's still like a 10%.
$1,000 can make a difference. Wow.
Yeah, like that's another GPU in some cases,
right? And that makes a difference for Resolve. That's a big deal.
Yeah. So that plus the fact that you don't have to be using the high performance power profile. That's kind of why I gave Threadripper Pro the edge in Resolve. So summarize for like video and photo stuff, Xeon-W either matches if it's lightly threaded if you're in high performance power profile, but if it's a bit better threaded of an app like Premiere Pro, DaVinci Resolve, I'd give a slight edge to Threadripper Pro. So honestly, for like all of my stuff, I don't think we're going to be using Xeon-W, which, I mean, it's not a core focus of this level of Xeon anyway, but right. But that's probably not where we're going to be using it.
All right, right on. Kelly, do you want to jump in?
Yeah.
All right.
So go ahead and go to my.
Just Kelly, right before you start.
Yeah, go ahead.
I just want to throw in here, just for everybody that's on the stream, my results are great for the Xeon-W.
Yeah. Wait, we're leaving best for last.
Most of my stuff,
the good news comes.
The 32 core even like way outperforms the 64 core Threadripper Pro. Okay, which makes it a bargain. But I will explain. When we
spoilers, man. Spoilers.
I just don't want to lose anybody, you know. But yeah, Kelly, I'm really interested in your stuff. I was fascinated by some of the stuff that you saw. So
mine go weird.
Here we go.
All right. So starting with V-Ray for CPU rendering. Like a lot of people are moving GPU rendering anyways, but CPU rendering is still pretty popular. And the name of the game in CPU rendering is just core count. And there's just no way a 38 core is going to be able to compete anyways. So I wasn't expecting a whole lot. And unfortunately, the 38 core barely matches the 32 core Threadripper Pro
Wow.
at like $1,700 cheaper. So it really, there wasn't much to say there. Like it just doesn't compete at all. Balance
16 core is fine.
Yeah, 16 core, they're about even. I didn't include the performance profiles on these. There's a couple percent swing, and sometimes it was one way or the other. Like sometimes it's worse, sometimes it's better. So it really just, the summary of my articles just said, like, try it and see what it works for your system on the exact thing you're doing. And since it's just a like a checkbox in Windows to set it, like, might as well try it. But I didn't include on these graphs because there's just not a whole lot to talk about on my stuff. Cinebench multi-core, again, it's just, you need cores, and there's just not enough cores. And again, 38 core barely matches the 32 core. I think on Cinebench, when you do the power profile, the 32 core and 38 core flop. Like the 38 core ends up being just a hair faster, but about the same margin that the 32 is faster than 38 core. So it's essentially the same.
Better wash there.
Yeah.
So an aside though, real quick, is there a performance, or is there really a reason for like these platforms versus like Threadripper? I can't recall what you had, like Threadripper versus Threadripper Pro.
RAM, like
RAM. So that does come into play.
Yeah.
Okay.
The amount of RAM, especially. That's one of the biggest draws to CPU rendering, is that you're limited by either video RAM or system RAM. If you're doing GPU rendering, you're limited by video RAM. So you can go a lot higher, a lot bigger scenes with CPU rendering.
Gotcha.
So yeah, there is still a draw for these on like the super high end rendering workstations. And that'd probably be servers at that point anyways.
Okay.
Single core, I should have included the power on this one. This is the one where like the Xeons look pretty bad here, but then in the performance profile, they all kind of evened out a bit. Basically made everything about the same score. And that kind of lines up with what we saw with Matt's stuff, that lightly threaded is where the boost is going to come in. But again, Threadripper Pro is just such a great platform for rendering that it's just hard to compete. All right, Unreal. This is where things get weird. All right, so for building lighting, this is one where things scale pretty reasonably. For some reason, the Xeon 16 core did terrible, just really bad. And I ran this multiple times on both power profiles, and it was the same. Yeah, I'm not sure why it was so bad there. And then the 38 core is about equivalent to the Xeon 32 core. So like, there's just not a whole lot going on there. There's just kind of the tip of the iceberg for the 38 core in Unreal. It's going to get worse from here. Actually, compile shaders, 38 core did pretty good. Yeah, and compiling shaders is a extremely threaded. It's like a whole bunch of very small tasks, so it can be spread out pretty easily. Like there's, I think 6,000 shaders that are compiled in this test. So those are all like mini programs, basically. A shader's a mini program. So they can all just be pushed around pretty effectively.
Nice.
So there is, at this level, we're getting to a bit of a diminishing return on how much faster. Because you see that like the 64 core, this is in seconds. So it finished that process in 15 seconds faster than the 32 core. Like, is that really going to help? Does that make a difference for your money? Whereas if you were to go down to like a 8-core Intel processor, that would be, 5 times as long. So now
that's That's a huge price difference too.
Mhm.
To save 15 seconds, you're looking at nearly double the cost.
Yeah.
Wow.
Yeah, that's why usually the 32 is usually like the sweet spot for Unreal.
Okay.
Just because the 64 core is faster, and if you want to spend the money, it's you do get a better performance on like compiling shaders, building lighting, compiling code, all that kind of stuff. But just is it going to be enough to make it justifiable or not? That's kind of up to each person.
Yeah.
Well, because
Yeah.
some people they have like a system that all it does is compile code
Mhm.
all day, right? But you
Yeah.
don't do that with like compiling shaders or building lighting, right? You can't pass that off.
You can.
Oh, you can. Oh.
Mhm.
So
Yeah, a
someone
lot.
was getting like a dedicated system that like, yeah, we have a team of 20 game devs
Mhm.
and they just push stuff off onto this constantly. Maybe it'd be worth it then.
Yeah, usually they have. Usually it's done like overnight.
I
Like
see.
at the end of the day, everything gets submitted back to the central server, and then it's recompiled, and then next day everything's ready to go. You still want a decent shader compiling on the user end for whatever changes they're making and stuff, so they can get refreshes. But then the whole system gets refreshed in the server. All right, compiling source code. This is where things took a turn. So this is technically not Unreal Engine. This is Visual Studio 2019, which is what you have to use to compile Unreal Engine source code.
Okay.
So for some reason in here, the 38 core came in dead last by a long shot.
Yeah.
And if you were to look at like how this is scaling by the number of cores as you go down, the 38 core would be equivalent to about like 12 or fewer cores. So what happened, because we saw this long time ago, and I've retried with different power profiles, different versions of Unreal, and different versions of Visual Studio, different updates and stuff they've had. What would happen if you watch the task manager was that only 12 threads would be at 100% during this test. And the rest would fluctuate between doing absolutely nothing or occasionally would spike up and then go back to doing nothing. So it's 12 threads is the 6 cores. So that leaves the 32 cores. That's one of the processor groups inactive, whereas the 6 are the ones that got picked to run the code. So if it had even swapped that and picked the 32 cores and then left the 6, that would have been a better result, like by a long shot. I would have at least had it up there with the 32 cores, maybe a little bit faster, because then you get the additional bump occasionally from the other. But yeah, for some reason, and I haven't, I don't know if it's a Visual Studio problem or if it's a Windows scheduler problem or a combination. But yeah, it does not like to compile a code in Visual Studio on that 38 core.
So the way that it groups the processors is like it should be the 32 as like the primary, the CPU 0 or whatever, and then the extra 6 should be the secondary ones, right? Like that's how it should be.
I would think so. I don't know how it actually works on the
But
back end, but
it's
something is picking it wrong. Because like the 64 core, you see it's not like limited to a single processor group. The 64 core threadripper, it does phenomenal. But for some reason, it just had a really bad time with this 38 core. It just could not get it to do more than 12 processor groups, 12 threads at a time.
Yeah. I hope this is just like some funny business because it's like new architecture kind of thing. And like, they got to do some catch up kind of thing to work this stuff out.
That's what I'd think, but also like compiling code in Visual Studio, like they are like it's set for this. Like it should be like they're used to seeing more than 32 cores running compiling code. So I don't know why this processor did not like it. And we reported this to Intel a long time ago. New BIOS didn't fix anything. Updates to Visual Studio didn't do anything. Like I don't know what it is, but yeah. So for that reason, if I was to score everything compiling for Unreal Engine, I can't recommend the 38 core at all. Like, just avoid it if you're doing Unreal Engine work, especially if you're doing code compiling. If you're game dev, compiling lots of code, just ignore that. You probably want a Threadripper anyways. They're still getting way faster and cheaper. So yeah, it was not a great showing for Intel for Unreal.
Remember, wait for Don. Wait for Don. Don has good things.
I said for Unreal. It's just for Unreal.
Yeah. Oh, Kelly, I have to tell you. I mean, that wasn't the most of all of the stuff that you guys saw. You know, the kind of anomalies and stuff. That one disturbed me the most because I couldn't not figure it out. And you know, and it did okay on the shaders, right?
Mm-hmm.
And the same kind of thing should be going on in there. And so it should be good. I mean, so that was like, whoa, that is busted. I mean, something is wrong there.
To compile all that stuff, you need to compile shaders. You need to have Visual Studio installed anyways. Like, you need that to be able to compile everything in Unreal. So I don't know why compiling in Visual Studio by itself has a problem.
Yeah, that was just weird. That was really weird. But I mean, that one just like stuck out to me as like one of the craziest things I will historically put that down as one of the craziest things I've ever seen. And yeah, really disturbing. But you know, I just, you know, for what it's worth, AMD, the Threadripper, just a regular Threadripper, and Threadripper Pro as a build system, as a compile system. Yeah, they're crazy. I remember when the Threadripper was first launched, people, you know, ran Linux kernel compile benchmarks on it, and it was just like seconds. And it was like, people did not even believe. I did it myself, and I put it in a post, and the guys are like, no, that's not even possible. And it's like, yeah, it's really possible, and it works really, really well.
You talking about Gen 1 Threadripper?
Yeah. No, yeah. Well, no. The 64 core.
When that came out,
yeah. So that's like Gen, is it 2? The 64?
I don't remember.
I don't remember.
Whatever. Remember... When that one came out, it was like, whoa. Yeah, it just was crazy for that kind of workload. But Intel should be really good there too. So, but yeah, cores matter more probably than anything.
Mm-hmm.
Yeah, and honestly, you know, someone mentioned like, is it just growing pains with, you know, new platform? I don't think there's enough changed in this platform for there to be like growing pains.
No, it's weird.
Now, like the next, because I think supposedly isn't like Intel supposed to be like changing a whole bunch of stuff with a lot of their next ones. And like if they do, maybe there'll be more growing pains. But I feel like right now we're still kind of like iterating is what Intel's doing. They're just iterating.
Yeah. Well, this isn't the first Intel CPU over 32 cores, though, is it?
No,
it's just the first one like on this platform. Because I thought the other 64L, the previous 64L had like a higher.
Yeah, their previous was 28.
Oh wow,
was it?
On Xeon-W.
28 cores on the Xeons.
But didn't it on like Xeon SP?
Yeah.
Really?
Yeah.
I'm gonna check.
Yeah, this core count bump is new for the platform.
Wow.
Huh.
Crazy. Yeah, you could get a 56 core thing. You could have like a dual 28, and that's the high end. That's the 82 crazy.
I thought the Xeon Platinums had higher.
Yeah, the Xeon Platinums. Yeah, the 83 whatever's. They went up to 40 or go up to 40. But those are fairly recent. Those might be the same.
Oh no! That's this one.
Yeah, that's the same generation as this. It's just Xeon-W.
Yeah. This generation, Ice Lake bumps the cores up.
Yeah.
So this is actually something different for the platform.
Yeah, that's true. Yeah. I mean, before it was just you could get similar, but with two physical CPUs on like dual Xeon.
Yeah.
But I don't know how Windows handles, like we were talking about the logical processor groups. It might just like totally, like everything I read about logical processor groups is it tries to maximize, how many cores are in each group. But I doubt it would like pull, 28 and then another 4 from this other physical processor and move it over. I bet it just did like 2 separate ones.
Yeah, it's weird.
Which makes me wonder about like the 40 core or the 38 core dual Xeons. Like if you had 2 physical CPUs, would that mean you'd have 4 logical processor groups?
Who knows?
Oh, it's a good thing you only use dual Xeon when you're like doing like really heavy
Use Linux on that.
full load
stuff. All right, Don, your turn.
Okay, my turn, right?
Fast.
That
No, just
brings us around to something happening.
Yeah, 15 minutes.
Okay, oh, thank you. You put that up. Yeah, that's my blog post. I didn't do separate. Oh, I have to scroll over here, don't I? The first thing I want to say is just a little bit about what this thing really is. Okay, you have the server class hardware from AMD and from Intel, and on an Intel side, that's Xeon. It's Xeon SP, the scalable processor, and on AMD side, that's EPYC. And so you come down to the Xeon-W that we're looking at, and then Threadripper Pro. These are the single socket versions of those chips. Okay, so this is the high performance workstation processors. So I mean, EPYC Pro is, or I'm sorry, Threadripper Pro is EPYC Rome. It's actually an older generation of EPYC, right? so the next Threadripper Pro could be a nice jump. I think AMD is just holding this in reserve as a big club, right? But so and when I say workstation here, I'm talking about workstation in the traditional sense of workstation, back to like the Unix workstations from Sun Microsystems and DEC and IBM and HP and Silicon Graphics and stuff like that. The evolution of that is now to Linux workstations on this kind of hardware. Okay, so that I'm just putting that out there. The Threadripper Pro EPYC, that's a great architecture. Just AMD hit it out of the park with this. It's the best thing they've done since the original Opteron. And from everything we've looked at, it's just a great platform overall. Okay, but there's no question that that this stuff on the Intel side is really, their mindset there is on this workstation in the traditional sense kind of platform, and it's a great platform. The platform is, it's funny because they've caught up to the AMD platform at this level. So now it's 8 channels. It's got all the lanes. It's got PCIe 4. So these platforms are pretty much on par, and they're both great. Okay, they're both really great for serious, like scientific computing, data science, machine learning workloads that are need like heavy data processing on the CPU. Yeah, really good platforms, both of them. Okay, now Intel has a big advantage. Intel has a way stronger ecosystem than AMD. They've traditionally in this realm have had the best compilers for the x86 architecture. And this is historic. It goes way back, and it's always been a strength. And Intel also has fantastic performance libraries. Okay, and the thing in my work that is going to make the biggest difference is the BLAST library, the linear algebra library, because at the end of the day, numerical computing comes down to numerical linear algebra. And if you can do that really fast, you're going to get great performance on like a vast majority of scientific kind of applications, including machine learning and stuff like that. And the advantage that Intel has at this point is the AVX 512 vector unit. That is a 512-bit vector unit. That stuff can load into there, like these matrix operations. Stuff can load into there and do all these multiplies and adds in a single clock. So the amount of stuff that you can stuff into that vector unit happens every clock cycle.
Wow.
So that is a big performance gain. And this is twice as wide as the AVX2, but it takes a hit on the clock. The core clocks drop when this engages. And I think that's part of what has caused some of this craziness that's going on. It's just all of the memory management is so complicated. It's just unbelievable. But I think that's what's going on. But if you are in the Intel ecosystem, okay, if you're using Intel compilers or Intel performance libraries, then you cannot beat Intel for CPU performance if you're using their stuff, because it's highly optimized. And you will see that right here, okay? The HPL, High Performance Linpack Benchmark. Hope you can see that. Is that okay? Can you guys read anything on there?
It's okay to me.
Is it all right? Okay.
If not, I did post the link in the chat so you can follow along on your own.
Yeah. It's worth probably taking a look at the post because, you know, I won't say, well, yeah, it's probably worth taking a look at it. But you can see what's going on here. The top of the list there is, I've tested Ice Lake several months ago, because it was released as the Xeon SP first. And that was the best processor I've ever tested. I mean, almost 3 teraflops on that CPU system on the Linpack benchmark. The Linpack benchmark is what ranks the top 500 supercomputers in the world. So when you're hearing this stuff about petaflops and exaflops and stuff like that, that's what they're talking about, is the performance of this benchmark. It's classic numerical linear algebra. It's solving a big system of linear equations. Okay. It's a very standard kind of problem. So it's a good raw floating point performance benchmark. Okay. So yeah, the Xeons were really good. The last gen dual Xeon was also really good. And then right under that, the third one, I wonder if, can you see my mouse? Oh, I can't see my mouse. Maybe you can. Oh yeah, you can.
There it is.
Okay.
Hey.
Okay, here we go. This is the dual epic. Okay, and this is dual epic ROM. This is basically 2 Threadripper Pros right there. That's what you're looking at. Great platform. A lot of excitement when that stuff was launched. Really, really good. Okay, that's 100. This is 120 cores here because I ran it on Azure. I ran it in the cloud, and some of those cores are reserved for the virtualization layer that's under this from the cloud architecture and all that. But then right under that, we come down to these new processors. And so I didn't see a lot of scaling difference between the 38 and the 32 here. But still, the performance is really, really good. You know, that's like almost 1.8 teraflops on a single socket CPU system. That's like stunning. That's really, really good numerical compute performance. And let's see, what do we come down here?
It looks like the main advantage here is that AVX 512. Like that,
the AVX unit makes a huge difference because that accelerates the matrix vector operations.
Okay, because you're seeing, I mean, that's a significant improvement over the 64-core Threadripper Pro that's just below those two for half the core count. So it's got to be the AVX thing that's given that boost.
It is. The AVX 512 is twice the width of the AVX2, which is on the AMD stuff. Okay.
And then add in Intel probably has a little bit better optimizations in their implementations than AMD.
Oh yeah, way better. Yeah, because so this is linked with Intel's math kernel library, MKL. It's insanely optimized. The AMD here is using their library, their optimized library, and their Linpack binary executable. So their optimization, that's what's in here. But yeah, in this case, for this kind of stuff, both that 32 and 38 core Xeon-W outperformed the 64 core Threadripper Pro.
Yeah.
Okay.
Which was no slouch.
With no slouch.
Either.
That's great. Okay, that's great. Now this is very heavily biased. Intel has the big advantage here. Okay, because they've just got killer libraries.
Yeah, well, and it's a real advantage. It's not an artificial, oh, this benchmark is optimized for Intel. It's actually Intel has an advantage in this space.
In that space, in that kind of workload, if you are linking to MKL and you've got heavy linear algebra use in your code, it's going to do really, really well. It's been like that for a long time. But the rest of the stuff in here is just some historical stuff, all the way down to my little Ryzen 8 core, which is my machine, which I love, by the way.
It's so cute.
Even that's like really killer. You know, one thing here, we're talking about CPUs. All the CPUs are great right now. They're all good. Okay, they're all good.
Don's giving out participation trophies to all the CPUs.
Yeah. I mean,
he gets high fives to everybody coming across the line.
Yeah, it's really, really good. I mean, this little 8-core thing here is 10 times faster than the old Intel thing I replaced it with. I mean, literally 10 times faster.
I think I can.
Yeah, how far do you have to go back before 5800X beats the top supercomputer?
Oh,
30 years, 20 years?
Well, quite a ways, but maybe not as far as you might think. Yeah, it's great. Oh, hey, the high end stuff on these charts. Yeah, it's not that far back. It's really not that far back.
That's very cool.
Yeah, it's amazing. I mean, I've seen it. The first supercomputer that I was involved with the design and testing on did like 11 teraflops. You know, and that was like a $3 or $4 million machine, right?
Huh.
And that was in the early 2000s or something.
Now it's just like throwing a couple of A100s and
I've got another chart that I might throw up here. They will just like make your jaw drop when you see what GPUs actually do on this stuff.
I love it.
It's almost unfair for me to show it, but yeah, I better crank here because we're running low. HPCG is high performance conjugate gradient. This is the second recently added benchmark on the top 500 list. This is memory bound, and it's very typical of applications that are doing simulations and solving systems of differential equations and stuff like that. A lot of typical HPC workloads, and it memory bound. So when your application is limited by the back and forth from the memory, that's what this one measures. And of course, the more memory channels you have, the better you do. Mm-hmm. Yeah, that dual Xeon Ice Lake was fantastic. Okay, that's two 8-channel, that's 16 channels, and it just did really well on this benchmark. The dual Epic also really, really good, not quite as good. Let's see. Now we get down to what we're looking at. The 32 core Xeon-W did really well. Basically, the 32 and the 38 are the same because this is memory limited. And actually, the 32 did better, probably because it's just handling memory better. And these things peaked at when 24 cores were used. I scaled this. These things, this benchmark doesn't use all, you don't really need all those cores, but the cache really helps. So the bigger core count does help. And it's because the bigger high level cache. But then again, we've got both that 32 and 38 core Xeon-W beating out the 64 core Threadripper Pro. So it did, but this is memory limited. Okay, and these things have the same number of memory channels, but I don't know. I think Intel's cache layout may be actually really pretty good on this architecture.
Yeah, I noticed on this that the Threadripper Pro 64 core versus the Threadripper 64 core, it's almost exactly double.
Oh yeah,
Yeah,
Yeah.
because
yeah.
the
I mean,
Threadripper 64 is what, like fourth from the bottom there.
yeah, and that's going from the 4 memory channels to the 8 memory channels.
Yeah, makes
Yeah,
sense.
if you've got a memory bound application, you go a high core count Threadripper Pro thinking you're going to get this great scalability on your parallel code. If it's memory bound, then it's like, boom, it's just not good. So this just, I always like to err on the side of caution in recommended systems. It's like, yeah, get the one with the good memory channels, the memory performance, because when it's bad, it's hard to know when somebody's got a memory bound code. Anyway, so that's going on there. Now down to something where MKL, the math library here, really doesn't matter. Okay. NAMD, this molecular dynamics code, I love it for CPU benchmarking. It's got great GPU performance. Okay. You would be crazy to not use GPU with it, but it makes a really nice CPU benchmark because it's really good code. And this one scales out to supercomputer level also on the CPU or GPU. But here, there's going to be less difference here because, well, I don't know. This is pretty good discrimination here on the chart, but you can see the Threadripper Pro 64 core doing really well here. The dual Xeon with 56 cores, right about the same, and then also the Threadripper, the regular Threadripper 64, basically about the same.
Yeah.
This is not a memory bound code. Okay. So that's a noteworthy thing right there. Now we get down to the lower core counts, and you've got lower performance, and it's pretty consistent. You've got 38, 32, then you've got the Threadripper 32, and then the Threadripper Pro 32. It's a little bit different. I mean, it is a bit different, but it's not massive. Okay. But then it just keeps dropping down as you just drop the cores. Now, there's a lot of stuff that is like that. And Linus Torvalds ranted a while back about, why do they do these vector units? Just give me higher clocks and fewer cores, fewer fancy stuff, and double the clock speed. And he's absolutely right, because that would be way better than the things that we've been getting, right?
Yeah, too bad it doesn't work that way in the real
I
world.
know. Those days are gone. They're gone. STMV, this is the same code, but a bigger problem. This is like a million atom molecular dynamics simulation. It's a pretty good size problem. Again, there's not a whole lot of separation in these, but the dual epic and dual Xeon do really well. The high core count, Threadripper Pro 64, right up there, really nice. The dual Xeon with 56 cores, right up there. And then the Threadripper itself, 64, really good. Then we get the Xeons that we just looked at, and down to the 32 core Threadripper Pro. Pretty comparable in there. Okay, so this is a reality check for you. This is outside of the highly optimized Intel ecosystem. This is really good performance on this code, though, by the way. It's not going to improve with MKL, because I've compiled it myself and linked it, and it's just not a factor. Okay, it's not really a big factor. It does make a difference, but it's not massive. Okay, this little table here is really amusing, and I know a lot of people are Python programmers. You're doing machine learning stuff. You're going to be using Python. You're going to be using NumPy in some sense somewhere, because it's under the hood for a lot of stuff. And here again, there's some applications have been linked by default with Intel MKL. The Anaconda Python distribution, which is the dominant distribution in the machine learning world, is by default linked to MKL. And so you can see I only looked at the 38 core here and the 64 core. Threadripper Pro. And with that Anaconda distribution, with a up-to-date MKL library, yeah, that's really stunning. These are numerical linear algebra jobs again. This is Cholesky is a factorization, basically splitting a matrix up into some symmetric components, triangular components. These are pretty important kind of operations, but performance is fantastic here. Okay, the same now with a little bit older. This is key. A little bit older MKL here, a little bit older NumPy version. Performance on that Threadripper Pro is lousy. Okay, it's way down there, 4 times less, more than 4 times lower. Okay,
Weird.
Yeah, it is weird, but that's because back in those days, Intel crippled AMD. They gave it a non-optimal code path. Okay, now, actually, let me contrast that real quick because this is important. If you contrast this now with a little bit more a little newer NumPy and the current Intel MKL linked into NumPy, that's almost 3 times faster than it was on the old version MKL. And this is because Intel is actually sending AMD processors down a proper AVX2 optimized code path. So thank you for doing the right thing, Intel. They should have done this from the beginning. It would have saved a lot of animosity towards you, you know. But the performance is better. With that same basic setup right there, these new Xeon, it performs really well. It's linked with MKL. It's optimized for it. But the AMD stuff does way better if you're using the current stuff. So it's nothing to sneeze at. And if you're on the so there's no problem. I don't have any problem recommending the Threadripper stuff here. Okay, it's a good, really great platform. Another kind of weird thing here is just this. In CondaForge, I linked this with OpenBLAS, and this is a library that is not the same kind of thing as MKL, but it's not MKL. For whatever reason, the new stuff with Intel, it did lousy on OpenBLAS. It's terrible, and I don't know why. It didn't used to be. It used to be more like you would see something more like what you're seeing down here on this Threadripper Pro. Okay. But you'll also notice that with OpenBLAS, the Threadripper Pro does about the same now with OpenBLAS as it does with MKL. So you're okay here. If you're on AMD, you can use the MKL linked codes. You're going to be fine. It's not going to really be a big improvement if you go to like OpenBLAS linked code. Okay.
Cool.
Hopefully that shows you stuff. Should I show what happens if you use a GPU? We're over time, so I can probably show this because it's not official now, right?
I'm not sure that's how it works, but
yeah.
Do you want to see it?
Real fast.
Oh, okay. I have to stop that screen share. Okay, and I'm going to share. Oh, there we are. I'm going to share for anybody that's still hanging out. Okay, I'm going to share another chart. Share screen. Let's see. Oh, come on. Show me. This one. Okay. Yeah, Houston, can you?
Oh, you may want to minimize the preview.
Screen?
Yeah, minimize us. Here, I'll take it away for a minute.
Wait a minute. Okay, let me. I just messed up on the share. This is worth it. Hang tight, guys. Hang tight. It's absolutely worth it. Okay. Share screen. What have I got here? Share screen. Oh, I'm sorry. Okay, Chrome tab. There we go. Okay, this is what we want. Okay, now look at this chart. Okay, this is that Linpack benchmark. The supercomputers that you're hearing all this stuff, petaflops and exaflops and all that, the reason is because of GPUs.
Holy cow.
Okay. Yeah, holy cow is right, man.
41,000 gigaflops compared to just shy of 3,000 with that dual Xeon on your other track.
Yeah, it's insane. Okay, it's insanely better. Yeah, this is the NVIDIA A100 compute GPU. And man, the best CPU performance is down here in this little blue thing here. And that was that dual Xeon. This doesn't have this new one because, it didn't exist when I did this testing.
Wow.
But even one of them just blows it away.
Yeah.
Okay. So Matt always bugs me because like, yeah, well, Don's just going to tell you to use the GPU anyway.
I mean, when you see numbers like that,
and you're right. And out of fairness, yeah, the GPU, NVIDIA is just killing it. For the machine learning, AI, scientific computing, all this stuff, you've got GPU acceleration, and most of does now. Yeah, you got to use GPUs. Okay, this is double precision. This is this exact same benchmark. Okay, that's unique here on the A100. The consumer cards don't have good double precision. They have good single precision, but that's a lot of machine learning. That's really what you need. Okay. So anyway, I just wanted to put that up there for anybody that's still hanging out. So you can
the
see
cost difference. Like if you're gonna do CPU based, how many of those dual Xeons? That'd be
you would
so
have
expensive.
to have a pretty good sized cluster of CPU cluster to compete with a single node with A100s in it.
Yeah.
Yeah,
I mean,
it's crazy.
although, like what Kelly was talking about, like the rendering stuff, you do have way more in the way of like system RAM versus VRAM. Does that come up?
Yeah, absolutely. But you know what? Those GPUs, you can get those GPUs, and even with the one that I tested, just saw this today from Josh. Just posted this, 80 gigabytes on that GPU. 80, okay, not 8, 80 gigabytes on the GPU. That means you can do some really big problems on there. Plus, you can scale on multiple GPUs. So you've got that, in that case, 4 times. That was 40 gigs, but you potentially have 4 times 80.
160 gigs just in 2 of them.
You've got a lot. It's really good. If you can compute on GPU, then that's what I recommend. But CPUs are still very important. This new Intel platform, I highly recommend it. If you're doing a Linux workstation, you're doing machine learning, you need data science, you need to do a lot of processing back on the CPU side, this thing is very, very good. So is the Threadripper Pro. If you're in the Intel ecosystem, you're doing any kind of development there, go Xeon. Okay, you're crazy if you don't. Otherwise, coin toss. They're both great.
Awesome. I think, and on that bombshell, I think we'll wrap it up here because we are a bit over, but I appreciate everybody hanging out for that. That is just huge numbers that are hard for me, at least, to kind of wrap my head around how fast that really is. So that's super cool. Thank you guys, everybody, for joining us today on our quick kind of recap or roundup of the new Ice Lake Xeon-W 3300 series CPUs. Appreciate you all taking your time, and thank you all as well to the audience for joining us for this as well. And we normally do this on Wednesdays. Now we've moved it from Fridays to Wednesdays. We moved it to Thursday today because today was like the day for the launch. So Wednesdays, 1 p.m. Pacific is when we normally do this. In fact, next week, this is brand new for everybody. We have Jonathan Windbrush joining us. So that's going to be super cool. Very excited for that. So thank you, everybody. And we'll see y'all next time. Bye.
Yeah.